Hi everyone, welcome to i-tutor Academy. In today's session, we will start with Unit 3, subsection 8 of MMPC 010. It is specifying the regression equation. So, in last two videos, we covered till 3.7. Please refer that videos. And the first thing that the organization carrying out the regression analysis needs to do is to determine the range of variable which may affect demand for the product concerned. So example is here. And what is data collection? Okay, so once the relevant variable have been identified, the quantitative data need to be assembled for each of them, and this will be easier for some of the variable than others. And in dealing with an established product, for example, the firm might reasonably be expected to have access to a range of information regarding the variable which it controls, such as on price and advertising. And what may be more difficult to obtain, however, is information about competitors' products. And on this front, price data can be obtained through observing retail prices, as this information by definition is that the public domain and cannot be hidden. This requires continued market observation, perhaps over a long period of time. Likewise, information about product design changes can be obtained by buying the competitors' products, but this may be expensive if there are many on the market. And confidential, commercially sensitive information such as actual advertising expenditure by competitors and their proposed new product presents much more difficult problem in terms of access and may have to be left out of the process altogether. And data on levels of disposable income, population variables, interest rate, and credit availability are easier to obtain, for example, from government statistics, but other variables are more problematic. Okay, so how can things like expectation and taste be measured? For instance, in this case, the available data, perhaps resulting from market survey, may be qualitative rather than quantitative. So it's depend on the data. Okay, some means of conversion needs to be found if they are to be included in the regression analysis at all. And these are the things which the decision maker needs to keep in mind while collecting and selecting data on the relevant variables. Once the first two steps have been completed, the next stage is to verify the likely form of the regression equation. There are two main forms which are used in practice: the linear demand function and the nonlinear or power function. Both treat the demand for the product as the dependent variable, while the independent variable are those which have previously been identified as having an effect on demand. Okay, so example also here, and the equation is also here, so please refer from your IGNOU study material. Okay, so in each cases, a term represents the intercept of the line drawn from the equation with the vertical axis, and the A and C terms represent the regression coefficient with respect to small letter b and c, okay, to own, price, and advertising respectively. So that is about that. And exponential form of the equation has the advantage that it can be rewritten to give direct estimate of the respective elasticities of demand for the independent variable. And where b and c, that is small letter, are shown, are the on price and advertising elasticities of demand respectively. This is much easier approach than calculating elasticities through use of the linear form, which involves using the equation. And to calculate the elasticities in each case, in this case, the value of p and q need to be obtained from the data set. Okay, activities here based on that, try to do it. And next one is estimating the regression equation. How estimating the regression equation? So consider frame with the fixed capital stock that has been rendered under the long term lease. So this is, we can explain through the example only, okay, because all these are equation based. Okay, so please go through this. And so here is one equation: y is equal to a small letter a plus b and capital X. So A and especially the manager is interested in estimating the coefficient A and B of the function. Okay. So that is equation. And here is hypothetical data on total cost and total output. So you can derive from there. So there is a better way. The statistician have demonstrated that the best estimate of the coefficient of a linear function is to fit the line through the data point so that the sum of the squared vertical distance from each point to the line is minimized. This technique is called ordinary least square regression, that is OLS, ordinary least square regression estimation, and a number of statistical package including Excel. Okay. So here is the figure: total cost, total output, and estimated regression equation. This is equation plotted on. This is figure 3.13. Okay. So total cost Y is here. Okay. So this is all based on the equation, and the table 3.3 is about summary calculation for computing the estimate of A, B. Okay. And please go through it. So it will help you. It's all about equation based sections. And next one is decision under risk. What are the decision under risk? The focus of this section is to decision making under risk. The objective will be to develop guidelines for making rational decision given the decision maker's attitude towards risk. Attitude towards risk may be of three types. So one type is a risk seeker, is one who prefer risk given a choice between more or less risky investment with identical expected money return. He will select the riskier investment. And next one is a risk averter, is one who faced with the same situation will select the less risky investment. And third is a risk neutral person, is one who faced with the same situation will be indifferent to the choice, and for him any investment is equally preferable to the other. And it is difficult to slot people in one of these categories, and you would perhaps have observed both risk averse and risk seeking behavior in the real world. And the analysis of risk is based largely on the concept of probability and probability distribution that are commonly encountered in elementary statistics. First, the term strategy, states of nature, and outcomes need to be defined. A strategy is one of the many alternative plans or courses of action that could be implemented in order to achieve managerial goal. And a manager might be considered three strategies to increase profit: build a more modern plan which may produce at low cost, and implement a new marketing program to increase sales, or change the design of product to decrease cost and increase sales. And a state of nature is a condition that may exist in the future and that will have a significant effect on the success of a strategy. An example: the manager may not be aware of the economic condition in the future. The possible states of nature may be normal, recession, or boom. And the outcome result in either gain or loss based on particular combination of strategy and state of nature. The decision maker has no control over the state of nature that will prevail in future, but the future state of nature will certainly affect the outcome of any strategy that he or she may adopt. The particular decision made will depend, therefore, on the decision maker's knowledge or estimation of how a particular future state of nature will affect the outcome of each particular strategy. Okay. And given set of outcome, that is x1, and the probability of each occurring, that is pi, three statistics relating to probability distribution can be used. So this is the equation, that expected value of mean is measure of expected return. So this is represented by like this. Okay. Though, so this is the statistics have a direct application in measuring the expected return and risk associated with any business decision for which a set of outcome and their probability have been determined. The expected value, standard deviation, and the coefficient will be referred to as risk return evaluation statistics. Having defined risk and reviewed some of the related terminology, the task now is to develop quantitative measure of return and risk and to show how they are applied in decision making. And we know that individuals have different preferences concerning risk taking. It is also important that such a preferences be identified and their effect on decision evaluated. And rational decision making requires that the expected return be determined and the risk be measured, and that there be informed information about the manager's preference for risk and the expected value, the standard deviation, and the coefficients of variation will be referred to as risk return evaluation statistics. Let us take an example. So please go through this example so you will uh, you know you will get more idea about this section. Okay, and this is all about the equation, and the table 3.3 is there, probability distribution for two investment alternatives. And decision tree also here. Some strategic decisions are based on a sequence of decision, state of nature, and possibly even strategic decision. And alternative strategies can be evaluated then by using a decision tree, which traces sequences of strategies and states of nature to arrive at a set of outcomes. And the probability of each outcome is found by multiplying the probability on each branch leading to that outcome. And a decision tree shows two or more branches at each point where a decision or event leads to the various outcome. The decision tree approach can be directly applied to managerial decision making. A firm entering a new market may decide to build a small or large plant. This has no probabilities, but there may be stochastic element associated with each decision. Example, reaction of a major competitor and the economic condition, and the competitor may react by starting a national, regional, or new advertising program. The probability of each occurrence will depend on the size of the plant and the possible economic conditions, and then probabilities may be recession, normal, or boom. And here also the probability will depend on the size of the plant, and the probability of each combination is found by multiplying the probability along each of the branches leading to the outcome. Example is here, please go through it. And this is a decision tree like this. Okay, so please refer your IGNOU study material also. You will get more idea. In between any doubts, you can contact us anytime. So this is about today's section. Next subsection we will discuss on next video. This is all about today. So for more MBA series, you just do like, share, and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOU MBA Complete Syllabus Coverage Classes for individual students, semester-wise subject with online flexible timing. For more details, contact on +91 623 827 1885